trying to get you some more time right now. So the test, good question. Oh, it'll be after spring break, yeah, because I mean we got the quiz tomorrow, so. Yeah, the test will be Wednesday after spring break, okay? So, yeah, Monday we'll be doing something, Tuesday will be test review, and then Wednesday will be the trig test. Combine all the quizzes and make it that, yeah? Well, that is the good news, right? I mean, it'll be, we'll have quiz on pretty much everything, so, well, I don't know. Yeah, that'll be the test, though. That'll be the test. Wednesday after spring break. Okay. Let's get into what we're going to do today. That goes in a different thing, I think. Okay. I'm just going to do it this way. There we go. Okay, so we're going to be graphing secant and cosecant today. Okay. So, to graph secant and cosecant, right, or to think, about secant and cosecant, it is super important to remember that the secant, okay, of x is equal to 1 over what? Cosine. Very good. Okay. And therefore, the cosecant of x is equal to 1 over sine of x. Okay. That is going to be crucial to our understanding of how to graph these things. Now, let me show you what our graphing calculator says. And we're going to graph secant. Okay, so we'll do 1 divided by the cosine of x. This is how you evaluate, or this is how you graph secant in your calculator. Okay, we do not use second cosine. Okay, and I can understand why you'd want to use second cosine. All right, I can understand why you want to use that. Cosine is -1 power. Mrs. Whitmire, something to the -1 power means 1 over that something. Shouldn't it be the same thing as secant? Well, it's not. It means inverse cosine, which is something, or cosine inverse, or arc cosine, which is something we'll see next unit, I'm pretty sure. Okay, but that does not work the way we want it to work. Even though, the way we've learned, about the -1 exponent and where exponents go for cosine and stuff, but it's just not right. It's 1 over cosine x. Okay? Make sure I'm in radians. I am. Okay, cool. And I'll do zoom trig to make it look nice. And so this is the graph of secant of x. Okay, right? And so you're like, how are we supposed to come up with that? All right? It's actually not that bad, and I'll show you here. Okay, so how do we graph this secant of x by hand? Okay. Well, again, we graph secant of x by thinking in terms of the reciprocal of cosine. Okay. Now, do I have a pencil? I guess I did have a pencil at some point here. Okay. So, how do we graph cosine? Because that's what we're going to start with here. So, we'll start with cosine. All right. And we're going to graph plain old cosine here. No transformations. Okay. So, I'm going to start, amplitude is 1. So, I'm going to go 1 and -1 there. Okay. And let's see here. I'll do 2 full periods just for fun. Okay. So there's 2 full periods, right? Cosine normally goes between 0 and 2 pi. And so then another 2 pi out would take us 2 pi to 4 pi for another full period. And we'll find all those half points and quarter points there. So pi in the periods. So that way we get all that, all the important points there. Okay. So, I'm going to graph cosine. All right, so let's see here. Cosine of 0 is 1, right? Pi over 2, 0. Cosine of pi is negative 1. Cosine 3 pi over 2 is 0. 2 pi is 1. 5 pi over 2 is 0. 3 pi is negative 1. 7 pi over 2 back to 0. And 4 pi back to 1. And so then there's that graph of cosine in there. Okay, like so. Now, I'm going to do the same thing here. I'm going to graph between 0 and 2 pi. And I think that's right. Okay. So here's an adjusted graph of the cosecant of x. And it's going, oops, I think I wanted to go from not 2 pi, I'm going to do 4 pi. So here's an adjusted graph of that cosecant graph from 0 to 4 pi. So there it is, right? And so it almost looks like here, what kind of behavior does it look like we have going on between some of these curves? Like, what does it look like we maybe have right here, and here, and here, and here? Asymptotes. And in fact, we do have asymptotes there. Okay, there are asymptotes there. Okay? So let's think about why that might be. Well, at pi over 2, the value of cosine is 0. Secant, therefore, at pi over 2, it will be the reciprocal of that. And what's the reciprocal of 0? What would that be? Undefined, right? Because 0, right, in order to kind of like take the reciprocal of that, we want to make it a fraction. So you can put it like over 1 or over 2, over 7, over 100, whatever, doesn't matter. Reciprocal of that, right, would be 1 over 0, undefined. And so for our graph of the secant here, I think I maybe misspoke before and said cosec. For the graph of secant, we're going to have asymptotes at pi over 2, at 3 pi over 2, at the 5 pi over 2, and at the 7 pi over 2. Okay? Because cosine, and we plug these things back into our cosine, it would be 0, or it would be 0, and so therefore when we take the reciprocal of it, it'll be undefined. And so we have all these asymptotes. Okay? Now, let me do some other easy values here for us to evaluate, kind of figure out for secant. All right? So for example, I'm going to jump in here to 2 pi at the very center. Okay? Cosine of 2 pi is 1, right? So therefore, secant of 2 pi will be the reciprocal of 1. What's the reciprocal of 1? Not negative 1, nope. It's just 1, right? It's just 1. So we have a point right there. Okay? Here's another. At 0, cosine of 0 is 1. What's the reciprocal of 1? 1. Another point right there. Okay? And at 4 pi, also got a point right there. Okay? We can go down to the negatives. Cosine of pi is negative 1. What's the reciprocal of negative 1? Negative 1. Okay? And then at 3 pi, cosine of 3 pi is negative 1, but again, the reciprocal of that is still going to be negative 1. Okay, so you got some points now. Right? Let's think about some other things in here. For example, some of these other angles that I'm going to, imagine in here now because I didn't write them in. But let's say, for example, that we had cosine, we had like pi over 3 graphed in here. Okay, let's say pi over 3. Pi over 3, right, is between 0 and pi over 2. It's like, maybe like right there, we'll say. Okay, what's cosine of pi over 3? Cosine of pi over 3 is 1/2. What's the reciprocal of 1/2? It's 2. So at pi over 3, like roughly here, we're going to go up to 2, which we'll say is like roughly there. Okay, because reciprocal. And so you can kind of see, all right, well, if we have this point and we have the 2, we're going to look something like this, right? Approaching asymptote. Okay. Now, if pi over 3 gives us a positive 1/2, its reciprocal is 2. Let's think about the next thing. So what about 2 pi over 3? What's cosine of 2 pi over 3? It's going to be negative 1/2, but then again, the reciprocal of that will be negative 2. So at roughly 2 pi over 3, we're going to be down like here at negative 2. And then in the third quadrant, let's talk about 4 pi over 3. Cosine of 4 pi over 3 will also be, cosine of 4 pi over 3 is negative 1/2. Reciprocal would also be then negative 2. And so then you can see, okay. And I think at this point, you kind of get the idea, right? And so, okay, and there it is. There's our graph. Okay? So that's all we have to do. That's all we have to do. We graph the sine, or we graph the cosine. We graph the reciprocal trig function and all of its transformations. Okay? So if I'm asked to graph, cosecant, but it's got all those different transformations in it, I graph sine, okay, with all those transformations, and then I just do the reciprocal part to then come up with the graph of cosecant. Likewise with secant and cosine. Okay? It's really just that. So again, that's why it's so important to have that cosine and sine down, because we use those to then get secant and cosecant. Okay? So let's try another one here. Okay, let's try another one. Let's do, let's graph y equals the cosecant of x plus pi over 4. So we'll do like we'll ease ourselves into this nice transformation. With just one little transformation. Okay? So again, cosecant is a reciprocal of sine, and so it still has the same period as sine, 0 to 2 pi. Okay, so we're going to put that x plus pi over 4 between the 0 to 2 pi, and subtract pi over 4 from both sides, so you get negative pi over 4 is less than or equal to x, is less than or equal to, and let's see here, 2 pi is 8 pi over 4, so 7 pi over 4. Okay? So we got to go from negative pi over 4 to 7 pi over 4. In this case, I'll just do one full period here. Okay, one full period here. Okay. So when we go to set up our axis here, let's see. So we're not shifting up or down, so we don't have to worry too much about adjusting our, the moving up or down our x-axis here. But we are going to have some negative x values, so we want to take that into account. Okay, so I don't know, I'll say negative pi over 4 is like right there. Okay, and so that'll be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, roughly something like that. And again, we're going to go to 1 and negative 1 there. Okay. All right, we got to find our midpoint and our quarter point. So again, midpoint, how do you find the midpoint of two numbers? What do we do? Add them and then divide by 2. So negative pi over 4 plus 7 pi over 4 is 6 pi over 4, which simplifies to 3 pi over 2. Divide that by 2. 3 pi over 2 divided by 2 is 3 pi over 4. Okay, so that's the midpoint there. Again, negative pi over 4 plus 7 pi over 4 is 6 pi over 4. 6 pi over 4 simplifies to 3 pi over 2, which then divide that by 2, 3 pi over 4. Multiply by 1/2. Okay. Then we'll do the same thing for the quarter points. Negative pi over 4 plus 3 pi over 4 is 2 pi over 4, which simplifies to pi over 2, but then divide that by 2, pi over 4. Okay. So pi over 4. And then 3 pi over 4 plus 7 pi over 4 is 10 pi over 4, which simplifies to 5 pi over 2, but divide that by 2, 5 pi over 4. Okay. Okay. So again, before I go to graph the cosecant, I'm going to graph its reciprocal. What's the reciprocal of cosecant? Sine, good, yeah, sine. So sine of x plus pi over 4. So I'm going to do that in pencil here. So I'm going to plug in that negative pi over 4. Negative pi over 4 plus pi over 4 is 0. Sine of 0 is 0. So I got a point there. 0. Okay. 0 is not one of my quarter points. I'm going to skip it. Okay, I'm going to pi over 4. That is the quarter point. So I plug in pi over 4. Pi over 4 plus pi over 4, okay, is 2 pi over 4, or pi over 2. Sine of pi over 2 is 1. 3 pi over 4 plus pi over 4 is 4 pi over 4, or pi. Sine of pi is 0. 5 pi over 4 plus pi over 4 is 6 pi over 4. 6 pi over 4 is 3 pi over 2, which is then sine of 3 pi over 2 is negative 1. And you get the idea. There's the pattern. Okay? And so then again, and you don't have to draw in the curve there if you don't want to, but I'm going to just because we're still learning this here. Okay? So, for this graph of cosecant, where will our asymptotes be? At what x values will we have asymptotes? What are our x coordinates for asymptotes here? Negative pi over 4 is going to be one of them. 3 pi over 4. 7 pi over 4. Okay, at all of the places where the sign was 0. Okay. Cosecant of x plus pi over 4 at pi over 4 is going to also be 1 because its reciprocal is 1. And at 5 pi over 4, negative 1's reciprocal will still be negative 1. Okay? And I'm not going to make you guys come up with more points here. You can just, realize that, okay, we're going to have, just kind of this like parabolic-like shape here. And so we're just going to graph it like that. Okay? If you want to come up with points there to be more precise, you can, but I'm not going to make you do that. We can just do this. Okay? And I erase away the little help that I had, and there's the graph. Okay? We're going to do one more, and then I'll get you guys started on your assignment. Okay? So any questions on any of that before we move on? No? All right. Let's do another one. Okay, and this one will make it more special. Y equals the secant of 2x plus 3 pi plus 1. Okay, this will be the last one we do here, but we'll make it fun. Okay. So again, I'm going to treat this secant like I'm graphing cosine. All right, so I'm going to put that 2x plus 3 pi between 0 and 2 pi. Okay. This will account for both the period stretch or shrink that the 2 is going to, transform, and then also that plus 3 pi is going to adjust us left or right there too. It accounts for both the horizontal shift left and right and also the horizontal stretch simultaneously. So we'll subtract 3 pi from both sides. Okay. 0 minus 3 pi is negative 3 pi. 2 pi minus 3 pi is negative pi. We'll divide both sides by 2. And so you get negative 3 pi over 2 to negative pi over 2. Ugh, negatives, Mr. Widmeyer. Right. And we'll just do one full period here again. We'll just do one full period. Okay, we'll just do one full period. All right, so because our x values are all negative, we don't want to have anything in we don't have anything in quadrant 1 or 4. We want to really include quadrants 2 and 3 here. So I'm going to draw my x-axis to the right here. Okay. And another thing we're going to take into account here is that we are shifted vertically up 1, right? And so I'm going to adjust my x-axis to be just a little bit lower from the middle to account for that, to accommodate that. Okay. Because you are shifted up 1, and I'm going to put a 1, like right there. Okay, I'm going to draw that new kind of like center line. Okay, again, I'm going to kind of arbitrarily pick where I put that negative pi over 2, so I'll say, I don't know, negative pi over 2 is going to be right there. Okay. And then if that's negative pi over 2, then this will be negative 2 pi over 2, and then negative 3 pi over 2 would be like right here. We gotta find our halfway point, right? So add them up, right? Just like James said before, add them up. Negative 3 pi over 2 plus negative pi over 2, negative 4 pi over 2. Or in other words, negative 2 pi. Divide that by 2, negative pi. And then the quarter points here, negative pi plus negative pi over 2, excuse me, is going to be negative 3 pi over 2. Divide that by 2, it's going to be negative 3 pi over 4. And then here it's going to be negative 5 pi over 4. Okay, so there are our starting points, stopping points, quarter point, midpoint, all that good stuff. All right, and so again, I'm going to graph the sine. So let's start at negative 3 pi over 2. All right, no, actually, I'm going to write that. Y equals, sorry, not sine, cosine. Mr. Wid. Trying to confuse everybody. Okay, so negative 3 pi over 2, plugged in here. Times 2 will be negative 3 pi, plus the 3 pi will be 0. Cosine of 0 is 1, plus 1 will give us 2. Okay, so I got to go up to 2 here on my y-axis. There we go. Okay, so negative 3 pi over 2, I'm at 2. Negative 5 pi over 4 times 2 is negative 5 pi over 2, plus 3 pi is, well, plus 6 pi over 2, so negative 5 pi over 2 plus 6 pi over 2 is going to be pi over 2. Cosine of pi over 2 is 0 plus 1, though, so we're going to be right there. Okay, and then negative pi. Negative pi times 2 is negative 2 pi, plus 3 pi is pi. Cosine of pi is negative 1, plus 1 will give us 0. And then hopefully you can see the pattern here. Okay, we're going to go back on the axis and then back above the axis there. Okay, so again, there would be the graph of that. Okay, now, this is pretty critical, right? So if you like tuned out, you're like, I got this stuff, there's no problem, you know, I'm not listening. You want to tune back in right now, okay? You want to tune back in right now. All right. Where do the asymptotes go? Now where x is equal to 0. Where the graph is at 1, right? Where our y value is 1. Okay? Right. Okay? So like here at the negative 5 pi over 4 is where you want to put your asymptote, not at the negative pi. But Mr. Widmeyer, at negative pi, the value of the graph is 0, and the reciprocal of that would be undefined. You're right. But that's not why the asymptotes happen. Okay? The asymptotes occur when cosine is 0, not when the function, not when the thing we're graphing is 0. Okay? Where is cosine 0? Well, if I plug negative 5 pi over 4 in here, 2 times negative 5 pi over 4 is negative 5 pi over 2 plus 3 pi. It's going to give me pi over 2. Cosine of pi over 2, okay, is 0. So therefore, secant of the pi over 2, which is this, what we'll get when we do plug in negative pi over 4, 5 pi over 4, secant of that is going to be undefined. Plus 1, undefined plus 1 is still undefined. Okay, so if this piece is 0, okay, that is then making this thing undefined. Okay, even though that plus 1's there, right, if this is undefined, if you add 1 to it, it's still undefined. So the undefined here is there and there. Okay? Mr. Lynn, how am I supposed to figure that out? Am I supposed to like think about this and I don't know, am I supposed to think through all that? You don't have to, no, because think about it this way, right? These points are like on the x-axis, but they're shifted up. So these are like the zeros still, but they just have to be shifted up 1. Okay? So these, you can still count those as just your asymptotes. I mean, you can still just kind of do it that way if you want. Okay? And then the other behaviors are still the same. So you'll have, this, and if you want, you can kind of like, draw that because it is going to continue. I'm going to go down. Okay, and then we'll go up this way. And again, you can put like a dotted line here because you don't have the rest of that graph, but you get the idea. It's going to be there. Okay. And then we get rid of this. All right. So there's the graph. Questions on any of that? Questions on any of that? Okay. So please, this happens like every year where I have students that they'll just put the asymptotes right through the zeros there. And I get it. I understand why you make that mistake, but that's not where, your asymptotes are going to go. It's when just that cosine is 0, and therefore the secant of that will be undefined. So that's the one little thing you just want to be aware of. Okay? Questions on any of that? All right, well, I'll give you guys an assignment here to give you guys a chance to practice it and see what you think now. All right. Homework then is page 337, numbers 15, 21, and 27 to 33, the odds. Okay? So 27, 29, 31, 33. So 6 problems. All right? 6 problems. Yes.
Is there time for me to do the quiz like right now?
Yes. So for those of you that did not do the timed trig quiz yesterday, I would like you guys to do that today. Okay, like right now.
Different thing.
Okay.
Different thing. This is mine.
Okay.
Remind
So.
me about the quiz that we're supposed to do tomorrow, but like I'm gonna be.
Oh, right. Okay, yes, we can have you get started on that.
Okay.
Hopefully we have enough time to have you finish it up. If not, I can call you for set though. Is that okay?
I have to go to 4 o'clock today, and that's where. Yeah, 4 o'clock.
Do they need you for the entire thing of sets?
No, I can probably come in and finish whenever I.
If we need you to, okay. Cool.
Yeah.
Anna, what was your question?
So I was asking for the quiz yesterday, so
Yes.
I might as well make it now.
Yes, we'll do that. So if you want to have your seat, I'll get those around to you guys. Okay. All right. Let's see here.
I'm gonna play Counter Strike. I'm not gonna be home.
Yeah, Grace, we'll get
till
you
1 or
going
2 in
here.
the morning.
We can get
So
these guys
yeah,
started.
you want to over. So I figured
On the
I'd ask them if I could do it today. I'm going to school tomorrow. I might not go for block though. I might.
Alright, so Andrew.
Nick, when are you coming in for assignment?
So far, yeah, mom was
Yeah.
I did the wrong thing, 44 instead of 49. For last week. I did 44 instead of 49.
Oh wait, yeah, Miss Ramona. I still need to take that.
The time quiz, right? I'll get you through. Let's. How about if Nick, if you want to take your seat and turn it that way, and I'll have to quiz actually this level 1.2 distracting for you. And then when you're ready, I'll just have you go over here, Andrew. And face that window. I'll have it be quiet, okay? Yes. Let me get you guys back. You talking about the time quiz? You talking about the quiz for tomorrow? Yes. Okay, folks. So who? Actually, I know who did.
Name of the game? That's what it's called?
Oh, I know. Okay, so folks, there's a handful of us that are going to be taking this time tree quiz, so I'm going to get you